What we're going to do now is look at a system of equations and try and identify the system type. We're going to try and classify it. Now, just looking at the equations, we may not know what happens, so we're going to start by graphing. First step when you're graphing is you want the systems or the equations in the system to be in slope-intercept form. Ours are, so we get to skip this step. Graph both of the lines. So as a reminder, and I'm going to color code. So this line I'm going to graph green, and then our next line I'll graph blue. So as a reminder on how to graph, we start with the y-intercept. The y-intercept is the constant, or the number that's all by itself. So in the case of my green line, -1. So on the y-axis, I'm going to go down to -1. And then we use our slope, or our rate of change, the number being multiplied by the x. In this case, if we turn that into a rate of change, we have a rise of 3 and a run of 1. So starting from my y-intercept, I'm going to rise 3, run 1. And again, I like to use my whole graph so that my lines are hopefully a little bit straighter and a little bit more accurate. And arrows on the ends of your lines. All right, our second line, y-intercept, the number all by itself is -5. So we're going to go down 5 on the y-axis. And then my slope, the number being multiplied by x, is negative. So make sure when your slope is negative that your line falls. So I'm going to go down 1, right 2. Remember, if you go down and left, a negative divided by a negative turns into a positive. So be careful when you have a negative slope that you either go up and left or down and right. You can't make both values negative or you'll end up with a line that rises. All right, so we're done with step 2. Step 3, identify the system type. So this is where we ask ourselves those 3 questions again. Now in this case, my lines intersect right about here, so that is the solution to my system. Now it's not a nice ordered pair, but whatever approximate ordered pair that is, if we substitute those values in for x and y into both equations, it will make both equations true. So that's one thing that I want you to start thinking about before we move into solving these. All right, so now we're going to classify or identify the system type. There is a solution, so that makes the system consistent. And because there's only one solution, they intersect at one point, the lines are independent of one another. And again, one solution. Last example. Step 1, we need to rewrite these equations in slope-intercept form. Or, if you like graphing using intercepts, these are in standard form, and glancing over them, they would both be easy to graph using intercepts. So I'm actually going to remind you of that instead. So I'm going to start, I will graph, this will be my red line, and then this one will be my purple line. So I'm going to start by finding the intercepts of my red line. One thing you can do is set up your table. Put your equation in between, make sure you get your entire equation. Start by substituting 0 for x. 3 times 0 is 0, so that cancels. Be careful you do not cancel the negative in front of your y. Dividing both sides by -2, we get a y value of -3. So we're going to plot the ordered pair 0, -3. All right, so my next step then is substituting 0 for y and solving for x. Again, 2 times 0 equals 0, so that cancels, leaving me with 3x equals 6. Dividing both sides by 3, we get x equals 2. So we're going to plot the ordered pair 2, 0, and that will give me my line. Try and use the whole graph even though you only have 2 points, because we never know what's going to happen with our other line. Where might they intersect? All right, I am going to erase the work here just because I'm running out of room. And graphing using intercepts, my purple line here, I'm going to set up the same table. Putting my purple equation in the middle. Substituting 0 for x. 6 times 0 cancels again. Again, don't lose the negative in front of your y. Dividing both sides by -4, we get y equals +3. So plotting 0, +3. And then solving for my x-intercept by substituting 0 for y. 4 times 0 cancels, leaving me with 6x equals -12. Dividing both sides by 6, we get x equals -2. So I'm going to plot the point -2, 0. Try and make my line nice and straight. And even though my purple line isn't real straight, now we are going to ask ourselves, is there a solution? Well, it doesn't appear to me that if I had drawn my lines a little bit straighter that they would meet. So I'm going to say there is no solution, which makes this an inconsistent system. And try these two questions.